Programmatic prompting differs from conversational prompting in one crucial way. Your prompts are usually templates generating output that other code will parse, so structure and machine readability matter as much as quality. Claude was trained to pay particular attention to XML-style tags for delimiting sections of a prompt, which makes them a reliable way to separate instructions from data. This matters most when you're interpolating untrusted or variable data, user input, database content, into a prompt. Wrapping it in tags makes the boundary between instructions and data unambiguous, which also has security value as a mitigation against prompt injection. Few-shot prompting, showing example input and output pairs, is even more valuable programmatically than conversationally, because you're often trying to lock down a very specific, parsable output format. 2 or 3 well-chosen examples, especially ones covering edge cases you actually see in production, will outperform lengthy prose descriptions of the classification rules. For tasks requiring multi-step reasoning, explicitly instructing Claude to reason before answering improves accuracy. This is chain-of-thought prompting, typically asking Claude to put its reasoning in one tag and its final answer in another. This has a direct engineering consequence. Your parsing code should extract from the answer tag specifically, not the whole response, and your max_tokens needs to budget for reasoning tokens as well as the final answer. A common bug is setting max_tokens too low for chain-of-thought prompts, truncating the reasoning before it reaches an answer. You can seed the start of Claude's response by including a partial assistant turn as the last message, which Claude will continue from rather than starting fresh. This is a powerful technique for forcing output format. Prefilling an opening curly brace strongly biases Claude toward continuing valid JSON rather than adding preamble like, "Here's the JSON you requested." It's commonly combined with structured output techniques. For programmatic use, you frequently need output your code can parse reliably, not prose. In order of reliability, tool use with a defined schema is the most reliable method, since Claude's output is constrained to match a JSON schema you define, and you receive structured tool call input rather than parsing free text at all. Prefilling plus explicit format instructions is next, asking for JSON, prefilling a curly brace, and validating or retrying on parse failure. And delimited tags with a strict prompt are simpler for one-off cases, but less robust. For anything production-grade, prefer tool use for structured output even when you're not actually calling an external tool. Building on the ticket triage example from the last chapter, a production-ready prompt combines several of these techniques at once. XML tags separating instructions, examples, and the ticket itself, few-shot examples covering edge cases, chain-of-thought reasoning, and a structured JSON output format with urgency and category fields. The same assistant gets extended with real tool calls in the next chapter. Take the triage prompt, implement it against the real API, and deliberately feed it 3 ambiguous tickets, ones that could plausibly fall into 2 categories. Check whether your few-shot examples need to cover that ambiguity explicitly to get consistent classifications. To recap, XML tags reliably delimit prompt sections and create an unambiguous boundary between instructions and interpolated data. Few-shot examples are especially valuable for locking down consistent output formats. Prioritize edge cases. Chain-of-thought prompting improves reasoning accuracy, but requires budgeting max_tokens and parsing only the final answer. Prefilling the assistant turns strongly biases output format. And for structured output, prefer tool use with a schema over prose parsing whenever the use case is production grade.